Okay, so the next problem we have is the largest unique number. We have an array of numbers and we have to calculate the largest number from it. That must be unique. Okay, so here you can see the largest number here is 8, but it's not unique. So if it's not unique, then we need to find the largest number that is unique, that is largest, and that's also should be unique. Okay, so how do we solve this problem with the hash map? To solve this problem, we utilize the hash map to track the frequency of each number in the given array that we did for the previous example. So the key idea here is to iterate through the array and then regarding the each number in the hash map. Okay, once we have all elements accounted for, we can then scan through the hash map focusing on elements with a frequency of 1. Okay, so the elements that have frequency of 1, which means this element doesn't appear 2 times in the hash map. Okay, so among these we identify the maximum value, and then this approach ensures that we effectively identify the largest number that appears exactly once in the array. Okay, so we are just leveraging the hash map for efficient frequency tracking and retrieval. So what we could do is we could just start by creating a hash map. So this will be our frag, and then we just loop over our nums using the far off n of nums, and so we can just use this frag because we are just storing the frequency of each number where it's not frags, it's frag. Okay, so once we have these frequencies in our once we have frequencies in our hash map, so we can just loop over the our frequency object, frag object, using the foreign loop. By foreign loop we can extract the key, so that key in frag. So if your key we are only checking for the key that have the frequency as 1. Okay, so this has frequency 1, so we are just we will just calculate the maximum unique value from here. Okay, so let's declare a global variable called like max unique. Initially it will be -1, because if it does and there doesn't exist a maximum value and it is largest, then we can just return -1. Okay, uh, okay, so we can just calculate the max unique value, which will be max dot max and max unique, passing in the max unique, and then we the second value is going to be the key, that is key is the number. So here freq of n, so it's not going to be c, it's n. So the frequency number, so if we calculate the maximum of it, so the key will be the 1 2 3 6 7 8. So since it's we are using the foreign loop, the key could be a string. Okay, so the string character, it's not going to be like this, it's going to be like this. So what we need to do, we need to just use the parse int to convert this string into a integer. So this will convert this key into an integer, and then in the end we can just return the max unique. So let's say let's run this and see the max unique should be 7 here, because 8 is repeating and it cannot be our max value. So run this. Okay, so the 7 is our largest value. Okay, so we just calculate the largest number that is also unique and its largest as well. Okay, so the next problem that we have is number of balloons. We are given a string and we need to determine the maximum number of times the word balloon can be formed using these characters from the input string. Okay, so each character in the string can only be used once. We cannot use twice the character. Okay, so we just need to use the character only once from the string. Okay, so using this example, balloon, so we can make two balloons out of this string, and using this input we cannot make a balloon from this string because there are some characters which are missing from this string to make a balloon word. So we cannot make even a single balloon out of it, and we can use this and this input returns, we can make two balloons out of it. Okay, so now to solve this problem, we can start by creating a hash map to count the frequency of each letter in the given string. Since the word balloon contains specific letters like B, A, L, and O and N. Okay, so these are the letters that the word balloon consists. Okay, with varying frequencies like L and O appearing twice in the word balloon. Okay, so you need to account for these in our hash, in your hash map as well. Once you have the frequency of each letter, on the next step is going to be like determine how many times we can form the word balloon. Okay, so now this is done by like finding the minimum number of times each letter in the balloon appear in our hash map. So we could say that the limiting factor will be the letter with the minimum frequency ratio to its requirement, like in the word balloon, and this approach could be like this approach ensures a balance between like utilizing the available letters and adhering to the letter composition of balloons. Okay, so what we can do is just let's just brainstorm this problem. Okay, so first what we do is we traverse through the string, and then we populate our hash map with the frequency count of each letter. So if the balloon B appear once, then its frequency is 1, and the L appear twice, then its frequency is 2, right? So, and then we just need to determine the maximum count. Okay, we will check our hash map to determine the maximum number of times the word balloon can be formed. Okay, for characters B, A, and N, the frequency in the hash map directly gives the number of times they can be used. Okay, they can only be used one because they are not repeating in our word balloon, because the in word balloon there should be two L and there should be two O, but the B, A, and N should appear only once in our word. Okay, so for L and O we need to divide their frequency by 2. Let's take an example. Say we have 4 L's and 4 O's. Then how many number of word balloon can be formed using this? Okay, so 4 L's we divided by 2, so we can only make the 2 word out of it. Okay, so if we have 2 L's, then we can make one balloon, and then if we have 4 L's and 4 O's, then we can make 2 balloons out of it. And then the minimum value among the counts of like B, A, and N, and L by 2 and O by 2 and N will give the maximum number of times the word balloon can be formed. Okay, and then in the end we will just return the calculate minimum value as a final result. Okay, so this approach is effective because it ensures that we account for the frequency of each letter required to form the word balloon. Using a hash map allows for efficient storage and retrieval of character frequencies. So first of all, we need to create a character count hash map. So our hash map is going to be char count because we are going to store the frequencies of each letter in the word string. So let's just use this one because this is doing the same, and we are just storing the frequencies of each characters, not numbers. So will be str, and let's say c represents the character. So we are storing the frequencies of each characters, and now we know that the B should appear once, and A should appear once, and N should appear once, and L should appear twice, and also O should appear twice to make the word balloon. Okay, so we can just have a min value. Initially it's going to be a positive infinity value. We can say number dot positive infinity. So we calculate the min value from here, and the min value will be the math.min, and we pass the min value, and the second value is going to be the frequency of that character. Like the frequency of B would be 1 or would be 0, and then again we have BA and the frequency of A could be 1 and 0, uh, and it could be 1 or 0, and then we have L. Okay, so the frequency of L should be 2. So make a word to make a balloon word out of it. Okay, so what we could do is we need to divide this frequency of L by 2. So it's going to be like this, and we need to also do it for O as well. Sorry, it should be like this. And then there is O, which is also should be 2, and O. Okay, and in the end we just return the min value, and now the main value could be a decimal value as well. So what we could do is we just return the floor value of that. So using the master floor, we convert the decimal to the integer and pass on the min value. Okay, so let's run this for these inputs. So for this we can make two balloons out of it, two balloon word out of it, and we cannot make a balloon word out of it. Okay, so let's just run this. Let's see. So there is an error, specs is not defined. So because it's not spec, it's char count. Okay, so now let's run this again. Clear the terminal, and okay, so yes, so we could make the from the string balloon we can make two balloon word out of it, and from this string we cannot make the even a single balloon because there are some characters which are missing. There is n missing from this, and there are some frequency of characters that are missing, so we cannot make a balloon out of it. And using this similar approach, you can choose another word from balloon, like could be like boy or boy, and you could see how many times this word occurs in your string, and basically you can use it for many variations.